Section 2.1 are functions in the real world. So before we can even get started on this section, we have to make sure that we're all on the same page about what a function is. So it is a rule of correspondence that assigns an element of A to exactly one element of B. And functions are represented in three ways. They're either going to be given by a table, a graph, or an equation, or you guys normally think of as formulas. So we're going to look at how do we deal with functions of all three of these types. And for most topics we cover in this course, we're going to have to get comfortable with dealing with these three types of representation. So when we talk about functions, we usually express their domain and range. So the domain are the inputs, the values that go into the function. So traditionally those are usually x values, but we can change the letter to anything we want. And the range are the outputs. That's the set of all y values that come out of the function. So let's look at how we deal with functions when they're given as tables, and how do we even identify whether in fact they are a function. So the first question says, well, how do you determine if a table of values represents a function? So what we want to do is, this says that each element of A goes to exactly one element of B. So it's okay, for example, if you have the same y value come out of the function. But what you can't have is an x value mapping to two different y values. So when we're looking at a table, what we do is we scan the row of the input variable and look for repeated values. So domain and range are given in set notation using curly brackets, because on a table we're giving a list of things, right? The parentheses and brackets we'll get into in a little bit later, right? And the values are written in sequential order with no repeats. So sometimes the table of values, the order will be out of order because it could have been a survey and people can respond in any order they want. But generally when we write a set, when we're talking about domain and range, we try to reorder the numbers in sequential order. And the reason we do that is if you're coming back later to look for a value, it's much easier for you to identify things if the numbers are in sequential order. So let's actually look at an example and see what I mean. So the example 1 says, do the following tables represent a function? State why or why not. If yes, give the domain and range. So we always assume when we see x and y, x are the inputs, y are the outputs. So if we scan across this row here, we see the number 5, right? 3, 2, and then we see a 5 again, right? And a 7, 10. So what this is saying is, if I want to know what x of 5 is, well, this column says 5 should give me 1 as a y value. But then this column is saying 2 will come out as a y value. So f of 5, it's saying, would equal 1 and 2. So this is not a function, right? And so for it to be a function, if I grab any one of these x values, I should only get one y out as my answer. So typically we can check for that very quickly by just scanning the inputs. We shouldn't see any repeats. And so our reasoning would be because 5 maps to two different y values. And our definition said it has to map to exactly one y value. If we look at the second table and we scan across the row, we can see that there are no repeats here. So this is a function. And we want to give the domain and range. So the domain, sometimes we do d colon, sometimes we write the whole word domain, same thing. And because this is a list of things, we use curly brackets. And now I'm just going to write every single x value that I see here, but I'm going to reorder it so that it's in sequential order. So we have a 1, a 2, a 3, a 4, a 5, a 6, a 9, and 11. So what we're saying is only x values that are on this list are allowed to be plugged into our function. The range are the y values that come out. Now, this particular function doesn't have any repeats on the y values. But if they did, like let's say that this number was 2.5 and so was this one, that's okay for the outputs, but when we write the range, we would only list that number one time because I just want to know the numbers that come out. I don't need to know how many times they come out. So in this case, I'm going to write these in sequential order. So 0.5, 1, 1.5, 2, 2.5, 3, 4.5, and 5.5. So now if someone came behind you or you were doing a part B, C, or D to this question and you wanted to know is, 7 in the domain of this function, well, you can very quickly scan the list and see, oh, 7's missing, 7's not in the domain, right? So when we write these in sequential order, it's really easy to come behind yourself and find things that are there or not there. So the next question says, and this is a typo, my bad. How do you determine if a graph represents a function? So what we do if we're given a graph is we do this same test, right? We want to scan across and make sure none of the x's mapped more than one y. And the way we do that on a graph is we use what's called the vertical line test. And sometimes we like to abbreviate that as VLT, just to make our lives a little simpler. The notation that we use is an interval because when you have a nice solid line, any x value can be involved in that. So we use brackets when the endpoints are included. We use parentheses for the endpoints when they are not included. And we always use parentheses around infinity, whether it's positive or negative, because infinity is not a finite number. So a combination of square brackets and parentheses is allowed, and so use union to connect the intervals as necessary.